Welcome to this explainer. We're right in the middle of a massive paradigm shift in the world of deep tech and engineering right now. There was a time when if you said the word rocket in India, literally only one name came to mind: the massive government agency, ISRO. Space technology was exclusively the playground of large national governments. But today, that has completely changed. Space access is democratizing fast, and a booming ecosystem of private startups is out there designing rockets and launching satellites into orbit. So who's actually driving this massive change in the Indian space landscape? Who is stepping up to pioneer this brand new frontier outside of those traditional government channels? Well, today we're going to look closely at one of the absolute vanguard companies leading this charge, Skyroot Aerospace. They are proving that with the right engineering knowledge, relentless innovation, and pure determination, private deep tech companies can totally transform the space industry. The difference between these two worlds is honestly kind of striking. Traditional government space programs are amazing. They're foundational, but their main goals are usually national research and defense, which, naturally, means longer development cycles. But then you look at the private space industry. The whole focus there is on lightning-fast innovation, slashing costs, and offering commercial launches. These private companies are opening up frequent launch opportunities for smaller satellite startups, which spurs incredible job creation and pushes the boundaries of engineering tech at lightning speed. All right, here's our flight plan for this explainer. First, India's private space revolution. Second, inside Skyroot Aerospace. Third, the Vikram rocket family. Fourth, next-gen rocket technology. Fifth, guidance, navigation, and control. And finally, some incredibly practical lessons for automation professionals. Okay, Section 1. Let's dive into India's private space revolution. Moving right along to Section 2, inside Skyroot Aerospace. So, former ISRO scientists Pawan Kumar Chandana and Naga Bharat Dhaka founded Skyroot over in Hyderabad with a really specific vision. Their mission? Making space launch more accessible, reliable, and affordable. They hit the nail on the head. They realized small satellite companies desperately needed a dedicated, cheap way to get into orbit, rather than just waiting around to piggyback on large, infrequent government missions. They saw this massive potential and just stepped right out to build a commercial rocket company from the ground up. To pull that off, they engineered a beautifully seamless end-to-end business model. It goes like this. First, you have a satellite customer, say a startup focused on Earth observation or communication. Skyroot takes that small satellite, handles all the complex payload integration, launches the rocket to deploy it into orbit, and boom, that generates commercial revenue. It's a fully integrated launch service for everyone, from research organizations to international clients. Let's look at the hardware in Section 3. The Vikram rocket family. Now, if you want to serve a wide variety of customers, you obviously can't just rely on a single rocket. That's why Skyroot developed the Vikram series. We're talking Vikram I, Vikram II, and plans for even more future launch vehicles. This scalable approach means they can perfectly tailor their commercial space missions depending on exactly how heavy the payload is and what orbital altitude the customer actually needs. Now, a super important concept for all these rockets is staging, and honestly, it's just brilliant engineering. Think of a rocket kind of like a giant elevator going up a ridiculously tall building, but with a twist. As it goes up, it drops its empty elevator cars to save weight. That's literally what rocket stages do. By shedding a stage once its fuel is burned up, the rocket gets radically lighter, which lets it efficiently hit the extreme velocity and altitude it needs to reach orbit. All right, Section 4, next-gen rocket technology. Looking under the hood, rocket propulsion at its core is just Newton's third law in action, right? For every action, there's an equal and opposite reaction. Shoot something super fast out the back, and the rocket moves forward. But here's the absolute crucial point. Space is a vacuum. There is zero oxygen up there. That's exactly why rockets have to carry both fuel and an oxidizer. They mix, combust to create super high-pressure gases, and blast out of a nozzle as high-speed exhaust to generate all that immense thrust. Now, think about actually building these things. Traditional manufacturing is this grueling process of heavy machining, complex welding, lengthy assembly, the whole shebang. But Skyroot completely flips the script by using additive manufacturing. We're talking about literally 3D printing a rocket component, layer by layer, straight from a digital design. They completely bypass the crazy assembly times you usually see in traditional aerospace engineering. For a private startup, 3D printing is an absolute game changer.
I mean, it unlocks these wild, complex geometries that you physically just can't machine traditionally. It slashes the weight, cuts down the total number of parts by combining complex assemblies into one single printed piece, and lets you prototype insanely fast. When you're a deep tech company trying to innovate quickly, that kind of flexibility is everything.
So when you bring all this tech together, you get a beautifully orchestrated mission sequence. Let's look at Vikram 1. It kicks off with ignition and liftoff, powered by that first stage flight. Then, exactly like our elevator analogy, stage separation happens. The upper stages take over, pushing the vehicle into its final trajectory, and it all culminates with orbital insertion and successfully deploying the customer's payload into space. Section 5. Guidance, Navigation, and Control. This right here is the brain of the rocket, the GNC loop. And this thing operates at mind-bending speeds, literally running hundreds of times every single second. It starts with sensors, like an IMU or a gyroscope, figuring out exactly where the rocket is and how fast it's moving. The flight computer calculates that data against the planned trajectory. The control algorithm decides what corrections are needed, and finally it commands the actuators to physically steer the rocket's thrust. It is this continuous, ultra-fast loop of sensing, calculating, and correcting.
And finally, Section 6, Lessons for Automation Professionals.
So you might be wondering, what does a rocket's brain actually have to do with a factory floor? Well, look at the direct parallel here. The aerospace GNC loop relies on sensors feeding a flight computer, which then commands actuators. In industrial automation, it's the exact same architecture. Sensors feed data into a PLC or SCADA controller, which then drives actuators, like motors or valves. Sure, aerospace has insanely strict reliability requirements, but the core feedback control logic is exactly the same logic used to run advanced manufacturing lines. For engineering students and automation pros out there, the playbook of deep tech companies like Skyroot offers some incredibly practical lessons. Solve a difficult real-world problem. Combine your disciplines. Mix mechanical, software, and electronics. Build prototypes and test them relentlessly. Automate wherever you possibly can to cut down human error. And remember the golden rule of scaling. Start small, build robust tech, improve it, and then scale up. And look, these aren't just abstract concepts. They are the literal bedrock of modern industrial solutions. Take DEVI automation solutions, for example. They apply these exact same principles in the real world to transform industries today. Whether it's complex PLC programming, SCADA integration, smart agriculture, or bringing in AI and IIoT for remote monitoring and predictive maintenance, that exact mindset of rigorous engineering, robust control loops, and continuous innovation is what drives their smart technology and powerful solutions for a better tomorrow. Skyroot Aerospace isn't just building rockets. They're absolute proof that world-class deep tech companies can be built right here. The democratization of space shows us that with the right engineering knowledge, the sky is literally no longer the limit. So I want to leave you with this. As the space tech, AI, and automation ecosystems just continue to explode, how will you apply these advanced engineering and control principles to build the innovations of tomorrow? Thanks so much for joining me for this explainer, and keep pushing the boundaries of what's possible.